JNEP's Ultrasound Enhanced Sulfur Dioxide and Particulate Control (USPAC) technology applies multiple absorption enhancement technologies to achieve high sulfur dioxide removal efficiency, while significantly reducing the aerosol formation and ammonia slip. By simultaneously applying fine particulate scrubbing and acoustic agglomeration technologies, the size of the particulates in the flue gas after sulfur dioxide absorption stage is enlarged, which greatly improves the fine particulate removal efficiency. The ultra-low emission of particulates is achieved by means of multi-stage, high-efficiency demister. JNEP's USPAC technology is mature and reliable. The process generates no secondary pollutants such as solid waste, wastewater, and carbon dioxide. And the byproduct of the process is the sellable ammonium sulfate fertilizer, making the process very attractive and viable, both environmentally and economically. The major functional sections of JNEP's USPAC technology are the ammonia storage and supply section, the absorber section, the pump and fan section, the ammonium sulfate post-treatment section, and the control section. Flue gas system. Flue gas from the ID fan enters the multifunctional absorber through the inlet duct. The absorption of sulfur dioxide is performed by improving the absorption system with optimized spray density, liquid gas distribution, and the oxidation process. As a result, high ammonia recovery and oxidation efficiency are achieved to minimize aerosol formation and ammonia slip while ensuring high sulfur dioxide removal efficiency and ultra-low emission. The guaranteed sulfur dioxide emission is lower than 35 mg per normal cubic meter, which meets the requirement of the ultra-low emission regulation, and the sulfur dioxide removal efficiency is more than 99%. The flue gas with sulfur dioxide removed carries droplets of the absorption solution, dust particles, and absorbent droplets. After the first demisting process, the flue gas enters the ultrasound-enhanced particulate control device. With the application of ultrasound, the fine particulates such as dust and aerosol particulates agglomerate through collision and resonance mechanism, resulting larger particulate diameters, which greatly improves the particulate and sulfur dioxide removal efficiency. Eventually, the flue gas passes through a multi-stage, patented high-efficiency demisting system, ensuring that the particulate emission meets the ultra-low emission standard of less than 5 mg per normal cubic meter. Absorption and oxidation system. The sulfur dioxide in the flue gas reacts with the desulfurization absorbent, ammonia, forming an intermediate product, ammonium sulfite and ammonium bisulfate solution. Sufficient air is fed into the system to oxidize ammonium sulfite and ammonium bisulfate to ammonium sulfate. Heat from the flue gas is used to concentrate and partially crystallize the ammonium sulfate solution. The flue gas is cooled and ammonium sulfate slurry with controlled solid content can be obtained. Therefore, the energy required for ammonium sulfate dehydration is greatly reduced. Ammonium sulfate post-treatment system. Ammonium sulfate slurry is further processed in the ammonium sulfate system through solid-liquid separation, drying and packaging to produce fertilizer-grade ammonium sulfate product. Compared with the wet electrostatic precipitator, WESP, JNEP's fine particulate control technology boasts the following advantages. The footprint of the system is smaller and retrofit can be done on the existing FGD unit. The fine particulate control unit is simpler and reliable and requires less maintenance work. It can be installed on the existing absorber. 30% to 40% less capital cost and 20% to 40% less operating cost. The power consumption is only about half of the WESP unit. No process water consumption and no wastewater discharge. JNEP owns 2 international patents and 56 China patents in the field of ammonia-based desulfurization, which cover all core technologies of ammonia-based desulfurization. The ultra-low emission FGD project for the No. 5 boiler at Wanhua Chemical, Ningbo Thermal Power Company Limited is the first ultra-low emission FGD project completed by JNEP and has become the demonstration project for the ultrasonic enhanced ultra-low emission technology. In this project, the boiler rating is 410 ton per hour. The design inlet flue gas flow rate is 560,000 normal cubic meter per hour, and the absorber inlet sulfur dioxide content is 4,500 mg per normal cubic meter. The absorber inlet dust content is 20 mg per normal cubic meter, and the dust content at the outlet of the absorber is not more than 5 mg per normal cubic meter. The sulfur dioxide content at the outlet of the absorber is less than 35 mg per normal cubic meter, and the sulfur dioxide removal efficiency is over 99%. Since the start of the operation in June 2015, the FGD unit has been running stably and showed excellent sulfur dioxide and particulate removal efficiency. This project has passed performance tests from third-party agencies such as Local Environmental Protection Bureau, Xi'an Thermal Power Research Institute, and Zhejiang Environmental Monitoring Center. So far, JNEP has more than 20 ultra-low emission projects in operation or under construction, covering petrochemical, power, refining, pharmaceutical, and iron and steel industries. The construction and installation of ultra-low emission units at the methanol plant of Shenhua Ningmei Group Limited, Coal Chemical Branch, Liaoyang Guocheng Power Company Limited, Sinoway Carbon Company Limited, and Jiantao Hebei Chemical Company Limited have completed, and all of the units are in operation and has met the ultra-low emission standards. Building every project into a monument, JNEP is committed to providing the best products and services to our clients. We regard project quality as our top priority and customers' full satisfaction as our ultimate goal.